Hi, and welcome to a video on difference of squares. We're going to do 6 examples. Some of the examples will have numerical values that are perfect squares, and some will not. So the first example is x squared minus 4. You set up two brackets, one with plus, one with minus, and you split up both of the terms by doing a square root. So square root of x squared is x, and then square root of 4 would be 2 and 2. So we can check this by FOIL to verify that this pattern does work. So x times x would be x squared. X times negative 2 would be negative 2x. 2 times x would be positive 2x. And then 2 times negative 2 is negative 4. The two middle terms, when you collect like terms, they become a 0. So this pattern does work. The second example we're going to do is a similar one where x squared, but instead of 4 we have a 5, which is not a perfect square. So we'll set up the two brackets, one positive, one negative. We split up the x's, and this time splitting up the 5 would be root of 5 and root of 5, because root 5 times negative root 5 would still give us the negative 5 that we want up on the top. The next example we will do is a difference of squares that has an expression in it. So we set it up as before. We have a perfect square expression minus perfect square number 4. This would work even if 4 was not a perfect square. So we set it up by splitting up x plus y squared into square root of it, which is x plus y without the square. And then same thing on the other bracket. And then plus and minus as before. Square root of 4 would be 2 and 2. Now this inner parentheses, because there's nothing multiplied there, we can remove them. And so we'll have x plus y plus 2 as one bracket and x plus y minus 2 as the second bracket. Example number 4, same idea. You set up two brackets, one with plus, one with minus, and then you square root each of the terms. So 6y squared and square root of 3x squared would be root 3x, and then you repeat it on the other side in the same pattern. Then you check if you can factor more. This one is not a difference of squares because of that plus. This one is a difference of squares because there is a subtraction, but the x is not a perfect square, and we should not be factoring this more because we want whole numbers to be the exponents of the variables. The coefficient could be an irrational number, but the variables we want to be of whole powers. Two more examples. Example number 5, same idea. We're going to set up two brackets. Square root of 100 is 10. Square root of a plus b all squared would be just a plus b. This time when you're removing the parentheses in the brackets, the first one doesn't have anything multiplied to it, so you could just remove it. So 10 plus a plus b is first bracket. But the second one, we have a negative that we have to multiply through. So it's 10 minus a minus b. And our last example where the coefficients could be not perfect squares, we set up two brackets, one with plus, one with minus. We do square root of 7, which is root 7 on both brackets. And then root 10 y power 3 and root 10 y power of 3. If you were to multiply them out, it would be 10 with y power 6.